All right, welcome to the deep dive. Today, we're jumping into something pretty wild, actually. Controllable AI music generation.
Yeah.
I mean, you've probably heard by now that AI can make music, um, but what we're really looking at today is like how much you can actually control that whole process,
Right.
right?
Totally.
Like how much can you be in charge of the creation?
It's a really cool thing. And that's the real focus of our dip dive here, I think, is to kind of like take all this research and look at how, how AI music has evolved, and then all the ways, both kind of big and small, that you can actually get in there and be in control, take the reins of this thing.
Yeah. And actually, we'll be looking at this really detailed analysis called Advanced AI Music Generation to really help us with all this.
Okay.
We're going to talk about how that's evolved. We're going to be talking about those ways you can control it. But then we're also going to be talking about the tech behind it all and some awesome tools you can start using, like right now, today.
Exactly. I mean, we really want to give you a clear picture of not just what these AI music tools are doing, but how you can really get in there and influence what they make to match your own vision.
Yeah.
How do you make it your own? How do you add your creative juice?
Right. So to kind of unpack this whole thing, let's actually go way back to like the very beginnings of AI in music.
Yeah.
And it might surprise you to know this, but like this idea has been around for a while. It goes back to the 1950s even,
Yeah.
like the 1950s and 60s with what they called algorithmic composition.
Right.
And even back then, you had things like the ILE suite in 1957. These were algorithms that could control basic things like pitch and rhythm,
Hmm.
really simple, but it was a start,
Yeah. Yeah.
It was that first inkling that, hey, we can make music with computers.
Right. And it's important to remember that even with these really early experiments, the composer wasn't just letting the computer go off and do its own thing.
Yeah.
It was about setting rules, defining parameters. And that, at its core, is about control, isn't it?
Yeah, for sure. And then in the 1970s, things started to expand a bit. Now, this isn't strictly music, but there's a great example from the art world. Harold Cohen's RNN program in 1973. It could generate original drawings and paintings, all based on a set of rules that Cohen programmed.
Right.
So you see this concept of what they call computational creativity, where like you define the parameters and then the AI creates within those boundaries.
It's really fascinating. And while, like you said, not strictly music, it demonstrated a principle that's very relevant to what we're talking about. You could codify artistic understanding, in this case, visual art, into a set of instructions that a machine could follow to create something original. It might have been limited to the rules it was given, but it was still creating. And that's a direct parallel to how we can control AI in music today.
Totally, yeah. So then we move into the 1980s. And this is where AI music itself takes a pretty big leap. Now, AI starts actually composing whole pieces of music. They were fairly simple, but still.
Yeah.
And then you have David Cope. David Cope and his EMI, Experiments in Musical Intelligence. This was a big deal because Cope was really into this idea of style emulation.
Yeah.
So his AI would analyze existing music, by human composers, and then it would like recombine the elements to create a new piece, but in that same style.
Yeah, yeah.
So the big advancement in control here was being able to actually influence the style of the music the AI was making.
Right, right. And on top of that, you also had the emergence of MIDI in the 80s.
Oh, MIDI.
And that was a huge deal for control, because think about it, MIDI was like this universal translator for instruments and computers.
Yeah.
All of a sudden we had this really precise language for actually talking about and manipulating musical events.
Right. Like the computer could finally understand what we meant when we talked about notes and rhythms and things.
Exactly, exactly. And with that came the potential for much more precise control. And going back to Cope's work with EMI, that was really showing that AI could learn and reproduce stylistic characteristics. So all of a sudden you start thinking, well, maybe in the future you could tell AI to create music in the style of Bach, or, with a jazz feel. Or
Like a rock ballad or something, yeah.
Exactly.
So moving into the 90s, things shift a little bit. Instead of AI trying to be like this solo composer, it starts being seen more as an assistant for human musicians.
Right.
So you start seeing these chord generators, these melody creators, tools that gave you some basic control over the harmony and melody. So the user could like nudge the AI in a certain direction, make it more of a partner in the process.
Absolutely. And that was a really important shift in how people were thinking about AI in music, wasn't it? It wasn't about replacing humans anymore. It was about augmenting what humans could do, giving them new tools, new building blocks, harmonies, melodies to play with and incorporate into their own music.
Right, yeah. And that brings us to the 21st century, and oh boy, things really start changing fast here.
Things explode.
They explode. This is when machine learning and deep learning come onto the scene, and that changes everything.
Totally.
Like, think about Sony's Flow Machines, 2016, Daddy's Car, a pop song entirely written by AI. And it wasn't terrible.
Yeah.
It was actually catchy, And that showed a huge leap in the AI's ability to really understand and replicate these different musical styles.
It really did. And you also had, around the same time, this whole new development, generative adversarial networks, or GANs.
Right.
And these offered a whole new way of controlling the style and the texture of AI music. It was a real game changer. And then, of course, you had the transformer networks in 2017, which revolutionized the way AI understood longer musical structures, which, again, leads to more coherent, more controllable compositions.
Right. And then Google jumped in with Magenta in 2016, focusing on melody and rhythm, but again, giving the user more and more control.
Mm-hmm.
And then OpenAI comes along with MuseNet in 2019, and this thing could generate these super complex pieces across all these different genres, all these different instruments.
Yeah.
And this is also when AIVA gets officially recognized as a composer.
Yeah.
It's crazy.
It is pretty wild when you think about it. I mean, the progress has been so rapid.
It's been insane.
And a lot of it comes down to these advancements in deep learning. I mean, that's really what allowed AI to start learning these really intricate musical relationships from huge amounts of data.
Right. Like suddenly it could process music in a much deeper way.
Yeah. And GANs were a huge part of that. They introduced this idea of a competitive learning process, which meant AI could start generating these much more nuanced and realistic musical textures. So now you have control not just over the parameters, but over the actual quality of the sound itself.
Yeah, like it actually started sounding good.
Exactly. And then those transformer networks, with their ability to understand context over these long musical sequences, I mean, that allows for much more sophisticated control over the whole form and development of a piece, from beginning to end.
Yeah. And then just in the last couple of years, we've seen this explosion of like these really user-friendly platforms, text-to-song platforms like Suno AI, Udio,
Right.
where you could literally type in a description and it'll create a song based on that.
Oh, it's amazing.
And you can control the lyrics, the genre, mood, tempo.
It's incredible how accessible it's become.
Right. And that's the big takeaway here. Like, sophisticated control over all these high-level musical things is now available to anyone, even if you don't know anything about code or, like, music theory.
Yeah. And that's really significant. I mean, we're talking about democratizing AI music creation here.
Yeah.
Suddenly, you don't need to be a, programmer or musicologist. You just need to have an idea. You can just, type it in, and the AI can help you bring it to life.
We've actually got a little summary of this whole progression.
Yeah.
You can see how, we started with that early control of pitch and rhythm, and it went through style emulation, basic harmony and melody control.
Yeah.
And now we're at this point where you can directly influence lyrics, genre, mood, tempo.
It's really remarkable.
It's amazing.
Just seeing that evolution laid out like that really puts it into perspective.
Yeah. Okay, so let's dig into the core ways you can actually take control right now. And our research has really shown that the most important thing is to start with a clear musical intent.
Absolutely.
Like, you have to know, what genre are you thinking? What style? What mood do you want to evoke? What kind of emotion? How long should it be? What's the overall structure?
Exactly. It's like giving the AI a good creative brief. The more specific you are, the more focused the AI can be.
Yeah, totally. And then when it comes to melody and harmony, you've got quite a few options.
Yeah.
You can usually set things like the key, the tempo, the genre. That's like the basic starting point.
Yeah.
But it gets really interesting when you start looking at reference melodies.
Oh, yeah.
Like, imagine you've got this little tune in your head. You can actually feed that into some AI systems, and they'll use that as inspiration, not just copying it, but using the shape of the melody, the rhythm, to create something new.
Yeah. It's a super intuitive and powerful way to kind of guide the AI, isn't it?
Yeah, it is. And some AI can actually suggest chords to go with the melodies it creates, which is pretty awesome. It can like instantly add this richness and complexity to the harmony. We're also seeing these advancements in what they call symbolic representations, which are allowing for even more nuanced control over things like, the emotional tone of the music or very specific melodic shapes. And of course, text-to-melody generation is getting really good, where you can just describe the kind of melody you want in words.
Yeah, that's right. I mean, it's amazing how many different ways you can guide the AI when it comes to melody and harmony.
Yeah, it really is.
Yeah.
And then rhythm and tempo control are also getting really refined.
Yeah.
I mean, you can obviously set the tempo, how many beats per minute,
Right.
but now some systems let you, like, influence those underlying rhythmic patterns in more subtle ways.
Yeah.
And even cooler, there's this thing called mapping temporal prompts. And what that means is you can, like, extract a rhythmic feel from a video,
Well.
or even, like, hum a rhythm into a microphone.
Mm-hmm.
And the AI can use that as a foundation for the music's rhythm.
That is so cool.
It is. And then there's dynamic beat customization. You can actually, like, tweak the rhythm as the music is being generated.
That's incredible. So you can really get in there and fine-tune the rhythmic feel on the fly.
Exactly. Now, when it comes to instrumentation, you're not just stuck with whatever the AI comes up with.
Right.
You can usually choose specific instruments, even have some control over the mix, like how loud each instrument is.
Yeah.
And in these symbolic music systems, they actually have things called instrument-related tokens.
Yeah.
It's like little tags that tell the AI exactly which instrument plays which part.
Interesting.
And then there's dynamic range control.
Yeah.
That's like the difference between the loud and quiet parts.
Right, right.
And that adds a whole other layer of expression.
Yeah, yeah.
And as we mentioned earlier, some AI models are actually trained specifically on the sounds of individual instruments.
Yeah.
So you get a much more authentic and, like, high-quality sound for that particular instrument.
Yeah, that's really important, especially if you want a specific instrument to really shine through in the mix.
Yeah, totally. Now, form and structure, that's how the song actually unfolds. You know, verse, chorus, bridge, all that.
Mm-hmm.
That's a bit trickier, but AI is getting much better at giving you control there, too. So with some generators, you can set parameters for the different song sections. You know, like, how long should the verse be? How many times should the chorus repeat?
Right, right.
And you can even control how those sections transition into each other.
Yeah.
And then you have these hierarchical models, which are really important here.
Yeah, tell me about those.
They understand music at these different levels of organization.
Right.
From, like, small phrases to the entire song.
Interesting.
So you have much more control over the overall narrative arc of the music, you know?
Yeah, it's like having control over the story the music is telling.
Exactly. And you can usually adjust the overall length of the piece, tweak individual sections, you know, really get in there and fine-tune the arrangement.
That's great. So you've got control over the broad strokes, and then
Yeah.
you can really get in there and fine-tune the details.
Exactly, yeah. So that's kind of the big picture stuff. But now we're going to get into the really juicy stuff, like how do you control those fine-grained nuances that really bring music to life, you know?
Yeah, this is where it gets really exciting. I mean, this is the frontier of AI music generation. We're not just talking notes and rhythms anymore. We're talking about those expressive details, the things that make music evoke emotions, make it sound human.
Exactly. So let's start with timbre. And that's basically like the sonic fingerprint of an instrument. You know, what makes a piano sound different from a guitar, or a violin different from a flute?
Right, right.
And there are these techniques like timbre transfer, which is crazy.
I know, it's fascinating.
Like Google Magenta has this thing called DDSP.
Yeah.
And it lets you take an existing sound, like a recording, and actually change its timbre,
Wow.
but keep the original melody and rhythm.
So you could have like a beautiful flute melody that suddenly sounds like a cello.
Yeah, exactly. It's wild.
Yeah.
And then you have AI vocal synthesizers, like ACE Studio.
Right.
And these things can, like, clone existing voices.
Really?
Yeah. Or even create entirely new vocal timbres. It's mind-blowing.
It really is. I mean, that opens up so many possibilities, doesn't it?
Yeah. And then there's neural music synthesis with instrument embeddings. And this is even weirder. You can actually morph between the sounds of different instruments.
Like blend them together.
Yeah, it's like crossbreeding instruments or something. And then you've got models like GANsynth, which are, like, specifically designed for better control over pitch and timbre. And even in the MIDI world, there's MIDI GPT, which lets you pick instruments from the general MIDI sound set.
Okay, so it seems like there's so many ways to manipulate timbre now.
Yeah, there are. And then there's articulation and phrasing. And that's all about how individual notes are played and grouped together. And that's where the things like velocity come in. You know, in MIDI, velocity controls how hard a note is hit.
Right.
And AI can now control that with so much more precision.
Interesting.
Like, it can make a note sound delicate and soft, or really harsh and loud, just by adjusting the velocity.
Right, right.
And these models are starting to understand musical phrasing. like where to put the emphasis in a melody, how to make it sound more human.
Yeah, yeah.
And they use these things called end-of-phrase tokens, which are like little markers that tell the AI where a phrase ends.
Interesting.
And there's actually research being done now on the link between those performance parameters, like velocity and phrasing and specific emotions.
Oh, wow.
Yeah, so like, can you make a melody sound happy or sad just by adjusting those parameters?
That's fascinating.
Yeah. And then, of course, there are these hierarchical models like MIDI DSP, which give you all this control over the performance, and advanced vocal synthesizers like Synthesizer V, which lets you tweak those vocal articulations in super subtle ways.
So we're talking about like really getting down to the nitty-gritty of how a note is sung or played.
Exactly, yeah. And then there's this whole area of microtonal variations, which is super cool. We're talking about pitches that fall outside the standard Western 12-tone system.
Right, right.
Which is what most Western music is based on. But like a lot of other musical traditions around the world, like Hindustani classical music, they use all these other pitches, these microtones.
Yep.
And AI is actually starting to incorporate the ability to generate music with these microtones. Google Magenta has done some really cool work with this. And there are even computational models being developed to understand and create music specifically within these microtonal systems.
So we're talking about AI being able to engage with a much broader range of musical aesthetics.
Exactly, yeah.
That's amazing. But I also wonder, with these microtonal systems, there's so much subtlety, so much nuance.
Yeah.
I do wonder how accurately AI can really capture that, especially as these technologies are still developing.
Right, yeah. And we also have to be careful about, like, potential homogenization, as AI becomes more involved in these different musical traditions.
Yeah, it's definitely something to be mindful of.
Okay, so we've talked a lot about what you can control, but let's actually take a peek under the hood now at the tech that's making all this possible.
Well, yeah, let's get technical.
So there's these things called recurrent neural networks, RNNs, and especially the more advanced kind called LSTMs.
Right.
Long short-term memory networks. And these have been like the foundation for AI music for a while because they're really good at processing sequential data, like, a series of musical notes. And they can learn patterns over time. Like if you feed it a bunch of Bach, it'll start to understand the patterns in Bach's music.
Yeah.
So you have models like Magenta's Melody RN, which uses LSTMs for melody generation. And LSTMs are good for like longer compositions because they solve this problem called the vanishing gradient problem, which is a whole other thing.
Right.
But basically, it means they can handle longer sequences of data without, like, forgetting what came earlier.
Yeah, that makes sense.
And you even have things like performance RNN,
Okay.
which are designed to, like, mimic the subtle variations in a human performance.
Wow.
So, like, how a pianist might speed up or slow down slightly or play a note a little louder or softer. Yeah. And then you've got bidirectional LSTMs, which use attention mechanisms. And those are used for like complex genres like jazz, where understanding the context both before and after a note is really important.
It's amazing how these different types of neural networks are being applied to different aspects of music.
Yeah, it is. But then came the transformer network.
Oh, yeah, the transformers.
And that was a really big step forward, especially for understanding those long-range dependencies in music and giving you even more control over the whole structure of a piece.
Yeah.
And they have these things called self-attention mechanisms, which are super complex. But basically, they let the AI weigh the importance of different parts of a musical sequence.
Right. So it's not just processing things in a linear way anymore.
Exactly. And you have Google's Music Transformer, which uses something called relative attention,
Right.
which is really good for super long musical sequences. And OpenAI's MISNet, which uses the transformer architecture to generate music that's harmonically coherent across all kinds of genres and instruments. And then there's variational transformers, VTs, which are like a mashup of variational autoencoders and transformers, which let you introduce variations in the music.
So you can have like a theme that's repeated but with slight changes each time.
Yeah, exactly. And then there's the anticipatory music transformer, which is wild.
Okay.
It's designed for these co-creation scenarios where the AI can like fill in missing parts of the music based on what's already there and what it thinks should come next.
Wow. So it's like jamming with the AI.
Yeah, exactly. And finally, there's the loops transformer, which uses this multi-stage cross-attention thing to combine textual descriptions and MIDI input to generate musical loops with really precise control over the instrumentation.
So there's a lot going on with transformers.
There is. It's like a whole toolbox of different techniques, all building on this really powerful architecture.
And that architecture is really good at capturing the overall structure of music. It's like it can see the big picture, the form, the harmonic progressions.
Exactly. And then, of course, we can't forget about GANs, generative adversarial networks. These are especially good at creating those really complex sonic textures.
Right.
And they learn the statistical patterns in music really well.
It's kind of like an arms race, isn't it?
It is. You've got this generator network, which is trying to make music that sounds real.
Mm-hmm.
And then you've got a discriminator network, which is trying to tell the difference between the AI-generated music and real music.
Okay.
And this constant back and forth is what makes the AI get better and better.
Yeah, so the generator's always trying to fool the discriminator, and the discriminator's always trying to catch it out.
Exactly. And you have things like GAN synth, which lets you control pitch and timbre in the audio.
All right.
MuseGAN, which is for creating multi-track harmonies.
Okay.
And then like CRN GANs, which are a combination of recurrent networks and GANs for generating these continuous musical sequences.
So GANs are all about learning the underlying statistics of music and then creating new music that fits those patterns.
Exactly, yeah.
Yeah.
But then how does the AI actually understand music in the first place?
Right.
And it all comes down to how we represent music to the AI.
Yeah, how we translate those sounds and rhythms into something a computer can work with.
Exactly. So there are a few main ways to do that.
Yeah.
Symbolic representations, especially MIDI, are super important.
Yeah.
MIDI is like this structured, really precise way to represent all the elements of music, like the notes, timing, duration, velocity, the instruments.
Right.
And it's really compact, easy for computers to work with. And you can change things like tempo and key without actually messing with the underlying performance data.
So it's like a very detailed digital score?
Exactly.
Yeah.
And it's used in tons of tools. Microsoft's Muse Coco for converting text to MIDI.
Yeah.
Google's Music Transformer for generating MIDI output. And even like AI-powered MIDI plugins for things like digital audio workstations.
Yeah.
Like Lemonade and HookPad Area. You can actually use AI to create MIDI parts right inside your music software.
It's amazing. So you can use AI to help you write specific parts or even generate a whole MIDI arrangement.
Exactly. And then you have direct audio waveform modeling,
Okay.
where the AI is actually generating the raw audio signal directly.
Right.
Google's WaveNet was one of the first to do this really well.
Yeah.
And now you have these super powerful models like Meta AI's Musigen, which can generate audio from text, or even a starting melody, and OpenAI's Jukebox, which can create audio with both music and singing.
So in this case, the AI isn't working with a symbolic representation, it's directly creating the sound waves.
Exactly, yeah. And the trade-off is you can get this incredibly nuanced, realistic sound,
Yeah.
but controlling it at the level of individual notes is a bit trickier
Right.
than with something like MIDI.
Makes sense.
And then there's latent space embeddings.
Okay.
And this is where things get really abstract. So latent space, it's like this compressed representation of music
Right.
in this lower dimensional space.
Okay.
It's hard to explain.
Yeah, it's a pretty complex concept.
But think of variational autoencoders,
Yeah.
VAEs. They create this like learnable map of musical styles.
Okay.
And different musical characteristics get encoded along different dimensions in this map. And by like moving around in this latent space, you can control things like the style or the instrumentation.
So it's like you're navigating a map of musical possibilities.
Exactly, yeah. And it's used for things like remixing, style transfer, taking the style of one song and applying it to another,
Oh, wow.
and even manipulating the instruments used.
That's pretty wild.
Yeah, it is. And then there are these audio embedding models,
Right.
which help the AI capture like the important features of a sound, like timbre and pitch. And the goal is to eventually create these things called disentangled latent spaces,
Okay.
where each musical attribute is represented totally independently. So you could have like one slider for pitch, one slider for rhythm, one slider for timbre, and you could just move those sliders around and very precisely control each aspect of the music.
So it's about getting more and more fine-grained control over all these different attributes.
Exactly, yeah.
Yeah.
But even with all that, research is still pushing the boundaries,
Right.
trying to find even more advanced ways to control AI music.
Always pushing the envelope.
Yeah. So there's this thing called probe-assisted fine-grained control, and that involves using these special probe models along with transformer architectures
Okay.
to actually go in and manipulate the AI's internal state so you can make very targeted changes to specific musical features.
Wow. So it's like going under the hood and tweaking the engine directly.
Yeah, kind of. And then there's fine-grained sampling guidance, or FTG,
Okay.
which is being used in diffusion models, which is a whole other type of AI architecture.
Right.
But basically, it helps align the music generation process with the composer's intentions, especially for things like improvisation and interactive music.
So it's about making the AI a more responsive and collaborative partner in those situations.
Exactly. And there are even techniques for like really precise bar-level control in symbolic music.
Okay.
So you can control what happens in each individual bar of music.
Wow.
Yeah. And then there's these hierarchical control mechanisms, which are really interesting.
Tell me about those.
So you have things like pyramid codec, which helps manage long sequences of audio,
Right.
and two-step VAE approaches, where the AI first generates short musical phrases and then arranges them into a song structure.
Okay.
And MIDI DSP, which gives you control over the notes, the performance, and even the synthesis parameters.
Wow.
Yeah. And then you have cascaded diffusion models, which can generate entire songs with control options at different levels. And even algorithms that use, like, repetition and similarity in the music to
Yeah.
figure out the hierarchical structure so the AI can understand how things are organized.
That's pretty amazing. So these hierarchical approaches, they're really reflecting a deeper understanding of how music is structured at different levels.
Yeah, exactly. So to actually see what's possible, let's look at some specific examples.
Okay, yeah, let's see these things in action.
So there's AIVA,
Right.
and AIV specializes in classical and orchestral music.
Okay.
And it gives you really detailed control over the harmony, the rhythm, the structure. You can even go in and edit individual notes and export it as sheet music.
So you can really fine-tune it to get exactly what you want.
Yeah, yeah. And you can guide it by specifying the genre, tempo, mood.
Huh?
You can even feed it your own audio or MIDI ideas as a starting point.
That's really cool. It's like having a super advanced orchestrator at your fingertips.
Exactly, yeah. And then there's Sound Draw.
Okay.
And this one is super user-friendly. You can do pretty much everything right in your web browser.